Alrighty then, the AND gate. Block, block, block. Input here, input here. Lever, lever. And then we'll place a torch here, here, here. Link those with redstone, and this is the output. Now, the output will only turn on if both of the inputs are on. Alrighty, an explanation of the logic. What we've effectively got here is if we take our first input here, run it out like that, and we put our second input all the way over here, run it out like that. We're running both of these inputs into a NOT gate to invert them. Then those inputs are being run into a NOR gate, like so. Now, seeing as these inputs are inverted, this NOR gate will only turn on if both of these outputs are off, which means that it'll only turn on if both of these inputs here are on, like so. Alright, alternative constructions. Once again, we've got the prerogative of either we may need more inputs, or we may need it to be torn thin. First, the no input situation. If we look once again at the explanation of the logic here, we can see that really what we've got is two NOT gates running into a NOR gate. Now, there's no theoretical reason why we simply can't expand it like so. If we add a whole bunch of these NOT gates here, these are our inputs, like so. And then run it into a NOR gate. So now all these inputs have to be on, all these levers have to be down before this input will turn on. So that's the way you can extend it to have more inputs. A compactor version of that for only 3 inputs looks like this. An input here, an input here, an input here, torch here, here, here. And this like so. And now, if we place levers like so, so, and so, again, this torch will only turn on if all the inputs are switched on, at which point we get the output. Alternatively, you might want to extend it so that it's long and thin, so that it can, say, fit inside a wall. If you want to do that, we take an input here, run it into a NOT gate. This NOT gate then runs into a NOR gate like so, the other input of the NOR gate being on top like this. This is the output of the NOR gate here, and then the other NOT gate running into the NOR gate is here, so giving us our second input like this, running over like that. Now again, this input will only turn on if both of these flicked. The AND gate. Uses. Right, for this I've built an illustration. Here's one I made earlier. These are almost always used as switches for enabling or disabling certain machines. So as you can see here, we've got a door, and currently this lever does nothing. If we go to the other side here, this lever is connected to one input of this AND gate here, which is in turn connected to this door. There's another lever here, which you'd say have in some kind of control room or control booth or something like that. Now, when this lever is switched on, this lever can operate the door. This lever is switched off. This lever does nothing. Other than that, these are, again, like all logic gates, used in sort of more complicated redstone circuits when we're building machines. But, you know, we'll come to that later. But, you know, this is the most common use of an AND gate. So yeah, AND gates. Pretty simple, really.